Hi, in this video again I'm going to talk about relationship of exponential and logarithmic function. So you have fx equals to 2 to the minus e to the power x. This is an exponential function, right? So at first we have to find the inverse function here, right? So I will tell you how to find the domain and range for the f inverse here. So you're going to let y equals to f inverse of fx, right? So then you know that fy will be equal to x, right? Will be equal to x. So then by using this technique, you can find the inverse of fx here. So you putting the y into this one, you have 2 minus e to the power of negative y, which is equal to x, right? So equal to x. So you're going to change the y as a subject, right? As a subject here. So then you slowly, you have 2 and you bring the x to here, 2 minus x, which is equal to e to the power of negative y, right? Or we can say that e to the power of negative y is the same as 2 minus x. To bring down the negative y, why you want the change become a subject, you put ln, right? You put ln, so you bring down, you have negative y, right? Negative y, which is equals to 2 minus x. So then you know that ln e will be equals to 1, right? So you have a negative y equals to 2, sorry, you have to put ln here as well. I forgot that you put ln both sides. It's a ln e negative y, right? Ln e negative y. So this one you bring down the negative y, and this one you ln 2 minus x, and the negative y you bring down here, and ln e is 1. So you have negative y equals to 2 minus x, ln 2 minus x, and y will be negative ln 2 minus x, right? Y will be negative ln 2 minus x. So if you you can replace the y back with inverse of x, which is equals to negative ln 2 minus x here, right? So the question may asking you to finding the domain and range, right? So as you know that the domain, okay, if I sketching the graph for fx, so the domain, as you know that the graph for negative e to the power of negative x, the graph is always below the horizontal asymptote. So you put the horizontal, the 2 here. So, okay, this will be your graph, the 2, right? 2, and the graph will be below the horizontal asymptote. Okay, you can view the video for the sketching of exponential function before you look at the sketching here. So 2, so e power negative x, so the shape will be going this way, right? It's supposed to be this way because of the negative is going down here, right? So they will intercept the y-axis, which is x equals to 0. So your y will be equals to 2 minus e to the power of 0, which is 2 minus 1, 1. So they were intersecting at 1. So if you sketch the graph happened to be this way, right? So, and you can read the domain from here. The domain for f, is always negative infinity to infinity, because f is an exponential function. So the domain is everywhere there is a graph. Means any value of x, there is an output, alright? So about the range, the graph does not exist for 2 and above, right? 2 and above. So it means that it's from negative infinity up to 2, right? Negative infinity up to 2, right? So this will be your range for f. So very easy. If you look at the domain for f inverse, so as you know that the concept of this one, the mapping here. So if you have this one to be f, this one to be x, and this one to be fx. So as you're mapping from x to f here, this is called f, right? So when you reverse back, this will be your inverse, right? So initially this one will be your domain of f, right? Domain of f, because this is an object and this is your image, and this one become the range of f, right? So when you reverse back from here back to here, so this one will become the object, right? So become the domain for this mapping for f inverse here, and this one will be your range for f inverse, right? So then you know that the domain of f is the same as the range of f inverse, and the range of f is the same as the domain for f inverse, right? And it has to be onto, all right? So if you see that, directly you can know that the domain of f inverse will be the range of f, right? Which is negative infinity up to 2. And the range for f inverse will be the domain, the range of f inverse will be the domain of f, negative infinity up to infinity, right? This will be further clearly show when you sketch the graph, okay? When you sketch the graph here. So, right? So, okay, this is the way you identify the domain and range for f inverse. You just find the domain of f and range of f, and you just interchange, and you will find the domain of f inverse and the range of f inverse here. So, now, you want to find the domain for f inverse and range for f, you want to show that this is true, you can actually sketch two of the graph on the same axis here. Alright, same axis here. So I'm going to sketch the graph for ln first, because exponent is already here. So for example, you want to sketch the graph for ln, right? So as you know that 2 minus x, the function inside the ln is very important. It must be greater than 0, and if you solve, you will get x less than 2, right? X less than 2. So it means that at 2 here, there is a 1, 2. Here, there is a vertical asymptote here. There is a vertical asymptote here. Alright, there's a vertical asymptote here. And the graph were negative, right? Negative. So, alright, so you know that there is a vertical asymptote here. Vertical asymptote. If you refer to the technique of sketching the graph for ln, the video, you will see that if it's less than 2 here, you have no graph. So it's either going up or going down. So if there is a negative here, you were choosing the one that going down here, right? So it means the graph will be somewhere around here, right? They will intersect the y-axis. They will intersect the y-axis. So for the y-intercept, for this graph, so the x have to be 0, right? X have to be 0. So when x is 0, you have negative ln 2 here. Negative ln 2 means they will intersect at the negative ln 2. Or if we want to go detail, we can find the x-intercept as well. So to find the x-intercept, so I need some space here. Alright. So hope you can follow. So to find the x-intercept for the f inverse, the x-intercept, right? The x-intercept, the y will be equals to 0, right? The f inverse x, negative ln 2x, this is your y. So the negative ln 2 minus x will be equals to 0. So if you 0 divide by negative 1, you have 0, right? And 2 minus x will be equals to, ln is log to the base e to the power of 0, which is 1. And you have x equals to 2 minus 1. You have x equals to 1 here. So it means they will intercept at 1 here. So if I'm sketching the graph, you see, sketching the graph. This is the graph for ln, negative ln 2 minus x. Alright, now if you look at these two graphs here, this is the graph for fx, and this is the graph for inverse of fx. So what can you find out, right? So if you see carefully that this will be the vertical asymptote 2, and for this one, this will be the y equals 2 will be the horizontal asymptote. One will be horizontal, one will be vertical, right? If here the x-intercept is 1 and the y-intercept here will be 1. You see that? If this is x-intercept 1, here will be y-intercept 1. So if you find the x-intercept, right, for this function, you are getting negative ln 2 as well. Alright, if you find. So clearly show that they are actually symmetrical about the line y equals to x. So if you or another thing, you look at this one. If domain of f is negative infinity to infinity, right, and the then the domain and the range here for f inverse, the range of f inverse here, so which is already shown here. The range here will be the range, the y value here, the anything that graph negative infinity to infinity, and the domain of f inverse here will be, there are no graph here, is negative infinity up to 2, and the range here is negative infinity up to 2. Can you see that? They are actually terbalik, you know, right? They are interchanging, you know. So now, if I'm going to sketch these two graphs together, okay, I'm going to sketch here. You will see that I'm going to put the horizontal asymptote here. Y2, right? So we must 2 here, right? 2, so you're drawing the line 2, right? So here you have a negative ln 2 because they are reflected. If 1 here, then there is a 1 here, right? So if you sketch the graph will be somehow looking like this, right? Sorry. So they were approaching the line y equals to 2. This will be the graph for fx, fx, and this will be the graph, the ln here, the graph for ln here will be the graph for inverse of x, right? So if you see carefully, they are actually reflecting about the line y equals to x here. They are reflecting, they are symmetrical about the line y equals to x here. That's why when you look at the domain and range, they are actually interchanged, right? So the domain of f will be the range of f inverse, and the domain of f inverse will be the range of f. So this is a relationship graphically, and through the domain and range you can actually see that. So now how about the relationship algebraically? Alright, let's look at it. Alright, let's show the relationship of this exponential function and this logarithmic function algebraically, right? So if they're given that fx to be 2 minus e to the power of negative x, right? Negative x. So, and the gx to be, negative ln 2 minus x, right? Let's say they're giving you fx to be this one and gx to be negative ln 2 minus x. So you can always find the composite function to see the relationship between these two functions here. So, right, you have fgx, fgx. So means that f, what's your gx? Your gx is negative ln 2 minus x, right? So you're going to put the negative ln 2 minus x into the function f. Negative ln 2 minus x. So you have 2 minus with e to the power negative of this. Negative ln 2 minus x. Then you have 2 minus with e to the power of negative, negative, positive. 2 minus x. So as you see that this is a, if you look at this, you have a formula where if e ln fx, so you are getting back the fx, right? So means you are getting back e ln fx, you are getting back the 2 minus x. So if you're solving this, you are getting an x. This is a very special relationship where the composite of these two functions, you're getting an x. So the reverse process also will be the same. The g fx. So which will be g, what's your fx? Is 2 minus e to the power of negative x, right? And you put inside into the g as an input for g. So you're putting inside here have negative ln 2 minus e negative x, right? So if you look at this, you will put this one into the g, your gx here, you will replace this by 2 minus ex. So you're solving 2 minus 2, you have 0, negative, negative, positive, e to the power of negative x, right? And you bring down the negative x forward, negative x, you have ln e. So negative, negative, positive x. Ln e is 1, so you're getting x also. This is a relationship where the fgx, equals to gfx and equals to x. This is only happen when the g is the f inverse of x, right? Or I said that the g is the f inverse of f, and you're getting to be x. Or I can say that the f is the G inverse of, is the inverse of G. Or I can say that the F here is the inverse of G. They are equivalent. So it means that once they are inverse to each other, they were getting the X here. So this is a relationship of the exponential function of this function and the logarithmic function. They are inverse to each other. Alright, I think that's all for this concept.